Oi. Kunyuk sudah dia.
Okay, so good day to our lecturer and everyone watching this video. Today our group is doing a recorded discussion for our operation management course. We are talking about our written report on Thomson Telescope Ltd. So before we start, let us introduce ourselves quickly. So my name is Delby Elsie John and my matrix number is BB2311029.
Hello, my name is HLD Eva Metal and my matrix number is BB23110731.
Hello, my name is Linda Nathan and my matrix number is BB23110302.
My name is Shairina Bila binti Abdullah and my matrix number is BB23110138.
Hello, my name is Kristen Leong Pitnyo, matrix number BB23110742.
Hello, my name is Nelson Chikwani and my number matrix is BB23110790.
Okay, so to give a short background, so Thomson Telescope Ltd is a part of Murray Engineering. 6 years ago, actually they set up a factory in South Wales to make telescope for Europe. So the Middle East and Africa. Actually, at first, this was very successful because it cut delivery costs. But recently, their selling growth has stopped. Even worse, their profit metrics, called ROCE, R-O-C-E, has dropped below the company target of 15%. So today, we want to look at the internal operational issue causing this problem. So anyone volunteer?
Let me do it. Okay, so thank you Delvi for the clear introduction. So by looking at the analysis itself, the company's failure is not because of outside market competition or bad economic times. Instead, it is 100% caused by internal operational failures. They expanded their product catalog over 200 standard telescope models. Managing 2,500 individual parts became a total nightmare. They're actually trapped in a bad cycle where sales department, the production floor, and their warehouse do not communicate with each other properly. This actually creates a big delivery delays and actually made the customer very angry.
Okay, wait. Now I see the point now. That disconnect show up heavily in the chronic sales and forecasting problems. So I think the sales team blindly promised the customer that their custom telescope will be made by and shipped within a strict 2-week window. But the reality on the factory floor is completely different with what they are promised. Because there is no proper schedule, actual production take anywhere from 3 weeks up to 12 weeks. This means the customer are forced to wait up 6 times longer than what they were promised.
What? That is a huge gap, Vincent. If people are always chasing land orders, they cannot find time to bring in new revenue. Because the sales forecasts are wrong, production turning become completely reactive and messy. Whenever the sales team panics about an order being late, the manufacturing manager is forced to split current production batches to handle this urgent order on an ad hoc basis.
Wait a minute, Kristen Lee. What is wrong with splitting a production batch for a moment to satisfy an urgent customer? Isn't it good for a flexible?
Okay, it looked flexible on the surface, Linda, but the impact is very bad. When you split an active production batch midway, you delay the original order. On top of that, you have to shut down the machine to completely reset up the tools and settings. This constant resetting wastes massive production capacity, creates server bottlenecks, curse idle machine times, and lowers factory efficiency.
Okay, I understand now, Kristen. loss is very clear. In fact, this week planning on the factory floor daily, they make their inventory management. According to our research data, Thomson Telescope has a very poor stock record accuracy that average only 40%. Think about it.
Wait, Linda, does 40% stock accuracy mean that 60% of the information on their inventory computer system is completely wrong?
Yes, Echa, 60% of the data is completely wrong. The create a situation where physical raw material are completely missing from the warehouse shelf, even though the computer system says they are available. Production lines are suddenly forced to stop completely because a tiny but essential component is out of stock, causing major manufacturing delays.
That is a big logistics breakdown, Linda, and the direct financial impact of having an inventory tracking accuracy of only 40% is devastating to the company's bottom line. Our finance director estimates that the cost of simply holding, securing, and servicing this massive inventory is roughly 20% per year. If the company keeps millions of dollars in unorganized stock, they are throwing away 20% of that value every year just on warehouse space, security, insurance, and handling costs. This massive waste of cash blocks them from hitting their 50% ROCE target.
You are right, Rachel. Actually, the financial loss is huge. I can see that, and our written report gives us excellent real data regarding the stock imbalance. For instance, look at the component part number B028. The warehouse has 1,630 units sitting on the shelf, but the factory actual annual usage for production is only 811 units. So that means they have over 2 full years of excess stock for that single part, tying up valuable working capital. Okay, so in other hand, look at component J017. The factory annual usage is 180 units, but the current warehouse stock level is completely zero. This complete imbalance explains why they have high holding costs but still suffer from constant component shortage.
Okay, I think that is actually an excellent example for the problem actually, Delphi. Because to fix this chaos systematically, our team actually conducted a full ABC inventory analysis, in which, in the report itself, we're using the standard operational of formula, which is annual expenditure equals to unit cost multiple by annual usage. Hence, we analyzed a sample of 35 core components, and the combined annual expenditure for this sample actually total up within 56,889 pounds. This calculation actually gives us a clear picture of where the company's money actually being spent.
Okay, we move forward to the report that I have sent the report at the group. We look closely about the ABC calculation summary table. The result match a very classic industrial inventory pattern. So we look at the category A. Out of the 35 sample parts, only 6 specific components falls into this category. However, these 6 parts alone make up a massive 73.3% of the entire annual inventory expenditure. So it costing a amount of 41,670 pounds. So this is a huge amount. This is are the high value business critical components. So if the Thomson telescope fails to manage or track even of these 6 parts, it immediately half of the production and drives up operational costs.
But if we compare that to category B and category C, does their management strategy make sense? Not at all. Category B contains 6 medium value components, accounting for exactly 15% of the total annual value, £8,531. Meanwhile, category C contains the remaining 23 components out of the 35 samples part. This means category C represents the vast majority of physical items, about like 65% of the item, but they only account for a tiny 11.7% of the total monetary spend, which is £6,688. Right now, management is treating cheap category C, screws and plastic caps with the exact same level of control as expensive category A glass lenses. This one-size-fits-all inventory policy is a massive failure.
Okay, I agree because they treat all items the same. They lack focus control. They waste hours counting cheap category C items while completely running out of highly expensive category A items. This data proves that Thomson Telescope needs to completely overhaul its warehouse control methods. They must implement a satisfied inventory policy based directly on our ABC analysis to free up cash flow and restore operational agility.
Now let us discuss about our operational recommendations. To fix the terrible 40% inventory record accuracy, one straightforward alternative solution could be to hire a brand new and large team of warehouse workers. These teams' single daily job will be to manually count all 2,500 different components by hand every morning and evening to make sure the computer is correct. What does everyone think about this idea?
Well, I'd like to provide some constructive feedback on that solution actually, Axel. While manually counting sounds like a simple fix, it is actually very, very hard, especially during these modern days. Which hiring a large group of new workers will also drastically increase the fixed labor cost. Hence, increasing labor expenses will actually hurt the profit margins and make it even harder for the company to hit its 15% ROCE target. Instead of throwing the manual labor at a digital problem, maybe the analysis could suggest that the company must implement a manufacturing resource planning, or to be called as MRP system. To frankly explain, an MRP system will automatically calculate exactly what materials are needed, what quantities, and what exact time based on live factory schedule. Hence, this actually could help the company to remove human error completely.
Okay, I want to support with the era about the MRP system because once the MRP system is live, we can directly program it and force our ABC inventory classification for these 6 critical category A items that take up 70.3 of our budget. We must establish a strict electronic control, high safety stock buffer, and automated reorder triggered with our supplier so that they never hit the zero stock again. So for category B, we can use the moderate oversight, and for category C, we can use a very relaxed, simplified bulk ordering method. So this allows the warehouse staff to focus 80% of their energy on the most valuable part.
Okay. To make sure the MRP system has perfect data, we also need to recommend a digital barcoding system for all raw materials, work in progress parts, and finished goods. Right now, Thomson Telescope only checks stock biannually, which is twice a year, causing data to rot down to 40% accuracy if Every single component is scanned with a barcode reader the second it arrives at the loading dock, moved to the factory floor or enter a delivery truck. We will have 100% real-time digital visibility, stopping order delays immediately.
So another great recommendation we developed is component standardization. Managing 2,500 custom parts for 200 telescope model is causing too much operational friction. If our design team standardizes internal screw, brackets and tubes across multiple telescope lines, we can buy part in bulk, simplify supplier management and massively reduce assembly confusion.
This directly ties into our sustainability considerations. From an environmental standpoint, component standardization and proper MRP scheduling prevent materials from becoming obsolete or damaged while sitting in a warehouse, reducing raw material waste. Socially, creating an integrated communication dashboard via an ERP platform will allow the sales team and production team to view real-time data together. This stops interdepartmental arguments, lowers daily employee work stress, and significantly improves long-term customer trust and satisfaction.
Wow, this has been incredibly productive and good discussion. Okay, so I will try to summarize our complete operational action plan for Samsung Telescope Ltd. So, we are recommending improving self-forecasting accuracy, deploying an MRP system integrated with strict ABC inventory control, introducing a real-time digital barcoding system like what Chris just suggested just now, and standardizing part to reduce supply chain complexity and breaking down communication silos using an ERP platform. So this comprehensive approach address their economic, environmental, and social challenge holistically. Okay, so based on our discussion, we have reached consensus on the best operational solution. So, does the entire team fully agree with this final plan?
Yes, I
Yes, we
completely agree.
totally agree,
Yes.
100%.
I agree.
Thank you. I like you guys' energy. Yes. So we completely agree. Okay, agree? Absolutely. This is the perfect way. Okay, so fantastic. We have achieved full team consensus. This officially concludes our recorded group discussion video for our operation management. So again, thank you everyone. Thank you so much for your hard work and deep insight today. It's really wonderful. And thank you to our lecturer for watching. So that's all from us. Thank you.
Thank you, Doktor.
Thank you, Doktor.
Bye.
Udah saya dah cukup ni, confirm.
Balik puasa kini berarti.
18 minit.